afternoon. I hope I make it fun for your lunch. I'm sorry. Well, my name is Macarena Farcuh, and I am an assistant professor and an extension specialist at the University of Maryland, and I am located in the main campus in College Park. And today I want to be talking about, are my apples ready to be harvested? Although I'll be talking a lot about apples, this really can be also applied to other fruits and even to some vegetables, and hopefully you find this very useful. So this is an overview of the presentation. We will first start defining what is fruit quality. Then we are going to talk about the different fruit ripening types and how that affects fruit quality. Then why is it really important to harvest apples at the correct maturity time? How are we going to determine this time? And then we are going to talk about how to do this, how should we collect representative samples, and specifically what are the things that we need to measure, which we call the fruit maturity indices, in order to determine the maturity stage of our fruit. And then we will just wrap up with some important considerations. And I also have a video that I wanted to share with you where we kind of do a practical demonstration of all of these indices that we are going to be discussing. So we'll start with what is fruit quality, and I always start asking you, what is fruit quality for you? What, if I say fruit quality, what comes or pops up in your head?
Tastes good.
What?
Tastes good.
Yes. What else?
Color.
Color, yes.
Texture.
Texture, great, great, great. Any other?
Smell.
Yeah, great. Yeah, so them almost everything. So yes, the color of the fruit, it is going to be changing as the fruit ripens on the tree. The texture, the fruit is going to soften, and that is going to make it more palatable for us, but it also brings the negative side of how to manipulate this fruit. The taste, which is generally composed by the sugars, as well as the organic acids that are present in that fruit. And the aroma volatiles, which we can also consider like the smell of the fruit. And it is important to consider that the taste and the aroma volatiles together is what will produce, or is what defines the concept of flavor that we hear about. So let's go into each one of these very briefly with respect to color. Generally, this change in color that we see in fruits from a greenish to a more reddish color that we see is due to the presence of the degradation of the chlorophyll, which gives us these green hues, and to the accumulation of these non-photosynthetic pigments, such as anthocyanins, which are going to be responsible for the red or the purple hues that we see in our fruits, or carotenoids, which are responsible for these yellow or orangish hues that we see in the fruits. With respect to texture, as we all know, fruit is going to soften as the fruit ripens, and this makes it a little bit challenging for the handling of the fruit, and also if we want to store that fruit for a certain period of time. And here I just want to mention that when we have this softening of the fruit or these changes in textures, they are generally due to three main aspects. It's modifications that are happening at the cell wall level of the fruit, also changes in turgor pressure of the fruit, as well as can be related with changes in the skin or the cuticle composition. Then we have another important aspect of quality, which is taste. And as I said, it's composed by the sugars as well as the organic acids that are present in the fruit. And here I just want to highlight that we always have to consider that it's about the quantity of these sugars and organic acids that are present. Also the composition. For example, in sugars, if we have more fructose in a fruit versus more glucose, a fruit that has more fructose is going to taste sweeter because fructose has a higher sweetness index as compared to glucose. So also the composition of these sugars and these acids are important when we are thinking about taste. And then finally, also it's all about the balance. If we have too much sugars and very little acids, the fruit is going to taste sweet, but if we have too much acid and too little sugars, we are going to go the other way. So we want to get this balance together in order to define the taste of our fruits. And then finally, we also mention aroma volatiles as an important component of fruit quality. Fruits produce a lot of volatile organic compounds, or VOCs, and they can be detected by over 650 types of olfactory nerve endings that we have in our nose. And they influence a lot in how we perceive the flavor of our fruits. It is going to be affected by the quantity of volatiles, but also the composition, okay? And here I just put some examples of different volatile families that can affect the flavor of fruits. For example, the family of the volatile called esters are the ones that are responsible for this fruity aroma that we get from the fruits. The alcohol volatiles are the ones that give this earthy aroma to the fruits when they are still greenish. The aldehydes are also this grassy, this bitter aroma, also present in these more green type fruits. And the lactones are an important volatile family group that is very responsible for the peach-like aroma that we perceive in fruits, specifically in peaches too. They are highly present there. So this is a very important component of quality that we sometimes don't talk much about, okay? But they all together make up the quality of the fruit. Now, together with that, now that we have defined fruit quality, I just want to highlight that there's two different ripening types, two different big classifications in which we as scientists really classify fruit to make it a little bit easier to understand all this ripening process. And we call them the climacteric and the non-climacteric fruits. So the difference here is that the climacteric fruits have the capacity of ripening once they are detached from the tree at the mature stage. But the non-climacteric fruits, they are not going to be able to ripen further after they are detached from the tree, okay? And here you have some examples of climacteric and non-climacteric fruits. Now, why does this differ between fruits? And I'm not going to get a lot in depth on the physiology of this, but this is just kind of general information that I think is important to understand. So it's generally this difference between the climacteric and non-climacteric fruits is due to their differences in respiration rates as well as ethylene production. So ethylene is one of the main ripening related hormones. If we have a lot of ethylene, the fruits are going to ripen faster. And in fact, when we want to keep our fruits longer on the tree or in storage, we generally try to use tools that will inhibit this ethylene production. But what happens here is, as you can see in this graph, climacteric fruits, if we look at the red lines in the graph, are going to be showing an increase in ethylene as the fruit ripens, and also there is a big bump, or big bump in the curve of respiration throughout ripening. And this is really what is going to keep the fruit ripening after we detach it from the tree or from the plant. But in the case of the non-climacteric fruits, we are not going to see this increase in respiration, and the ethylene contents or production is generally very low and very stable. So that's why these fruits do not continue ripening after we harvest them. And this has a lot of implications in case of when should we harvest a climacteric fruits versus a non-climacteric fruit, right? So now, with all those concepts in mind, I just want to talk a little bit about why is it really important to harvest apples, specifically at an optimal harvest date. And this is really because we want to ensure an optimum high-quality product. If we want to reach the best quality, we really have to try to harvest our fruit at the correct and optimum time. If we harvest the fruit too early, an immature fruit, what is going to happen? We might not have the sufficient red skin coloration, the sugars will not be high, there will be a lot of acidity in that fruit, the firmness is going to be really high, there's going to be a lack of flavor, and even the size can be affected. And then if we go to the other extreme and we harvest the fruit too late, when it's overripe, what is going to happen? There is going to be a higher softening rate. It is going to be more prone to mechanical damage and to pathogen issues. There's going to be a short storage potential, and there can also be development of these off flavors, which means like these fermented flavors that you can feel in these fruits when you eat them. So what we really want to find is this optimal time, which is very challenging. But the later the fruit is harvested, the shorter the storage potential it's going to have. And this is what I'm trying to exemplify with this graph here. So in the x-axis, you can see the maturation and the ripening period as it just progresses. And in the y-axis, you see the relative change. So what we can see is as the fruit ripens, there's going to be an increase in ethylene production, mainly talking about climacteric fruits. And that is going to be happening together with an increase in color, in flavor, in sugars and acids, in the starch index of the fruit. But on the other hand, what is happening as all of that is increasing is that our storability is decreasing because the fruit is softening, so the firmness is coming down, the acidity level is also coming down, the starch is coming down, and also there is a change in the background color. So our fruit is ripening, but at the same time, the storage potential of it is decreasing. So we have to have that in mind. So harvesting at the correct maturity stage is key for maintaining this fruit quality during post-harvest, even if it's a long or even if it's a short period, okay? So for me, like defining the optimal harvest time is really like a balancing act, because if you go too early, you will have this poor flavor, the fruit will never ripen, the consumers are not going to be happy with the fruit that you are giving them, there's not going to be a second purchase of the fruit maybe. But if you go to the other extreme, the fruit is going to be too soft, or it can be overripe, it can be more prone to decay, and you will have a poor shelf life. So how do we do this? How do we really have to determine this optimal harvest dates? So for that is that I want to introduce this concept of the assessment of what we call the fruit maturity indices. These maturity indices are going to be directly related with fruit quality, and they are going to help us predict this optimal harvest date based always on the target market. What are these maturity indices? There's many of these, and we are not going to go through all of these. I just wanted to mention them. But if we are talking about apples, and also in many other fruits, it corresponds to changes in background color when we see this change from greenish to a more yellowish or cream color in the fruit, the increase in size, the decrease in firmness, the disappearance of the starch, the increase in sugars, and in apples we can also see a change in seed color from a white, tan color to a more dark brown or black color. That's also an indication of changes in the ripening stages of the fruit. And then we also have changes in flavor, increases in ethylene production, increases in respiration rate, changes in the production of aroma volatiles, and also the loss of acidity. So I divided them here in maturity indices that are easier to quantify and that we can do with portable tools or even in the field, and these other maturity indices like ethylene production, respiration, volatiles, acidity, that we need to do more this in a lab-based setting, okay? In this presentation, we are mainly going to be talking a little bit more in depth about these ones that are possible to do in the field or with any portable instrument. So before going into that, I just wanted to bring to your attention these fact sheets that we have published already, which really talk a lot about this topic of how can we really determine this maturity and optimal harvest dates. And we describe each one of these maturity indices in depth, even the ones that are more lab-based. So if you are interested, you can also look into that resource for more information. And we also have the same in Spanish. So we have it in English and Spanish, exactly the same information if you want to reach out, or people that only understand Spanish can also read it. And I wanted to, a little bit out of topic, but I just wanted to use the opportunity. We also have developed with a colleague in the Department of Entomology extension blog in Spanish where we are constantly publishing blogs about different topics. It's not only about fruit maturity, we also talk about entomology, we talk really about different crops. So many different extension agents or assistant professors or professors are contributing many times to this topic. So it's a very good resource too, and everything is in Spanish. So now let's go back to our presentation. So we were talking about how important it is to determine these optimal harvest dates and how can we do this, right? We talked about the maturity indices, but before we even start going in depth into each one of these, the first big thing is to be able to collect a representative sample of fruits in which we are going to measure these indices. So how do we do this? It is important to bear in mind that the maturity of the fruit can vary within the same orchard block and even within the same tree. Okay, so these things you have to have in mind when you are collecting the samples that you are going to use for assessing your indices. Generally, the procedure is pretty simple and straightforward. You just select and you can label 5 to 8 trees in each block. Ideally, these trees have a similar vigor, crop load, and you try to avoid any border trees. Then you ideally start collecting fruits 4 to 5 weeks before your anticipated harvest date. You generally start sampling once per week, but as the maturity time or the fruit is advancing in their maturity, you can also doing 2 or more times per week, if the time allows, of course. And again, the sampling is very simple. We are talking about 2 to 3 fruits from the periphery of each labeled tree, as these fruits generally tend to ripen earlier than fruits that are in the inner part of the tree. We want to avoid sampling fruit with any disease or insect damage because that can produce an alteration in the indices we are measuring. And the important thing is to be consistent with our sampling method. We try to sample fruit with a similar size. We have to select fruits from both sides of the tree and hopefully at the same canopy height. And we try to collect samples at the same time of the day. And ideally, you try to evaluate your samples within 2 hours after you pick them, because the temperature changes can also affect the indices that we are measuring. Okay? So once we have our representative samples, we are going to go ahead and measure our maturity indices. So we will start, this is another thing I wanted to mention that I'm not sure if you are familiar with, but we actually do this for apples. We do weekly maturity assessments that we share with everyone through a newsletter that we have that is called Fruit Pulse. You can just follow the link and then you can just register and you will get these weekly maturity assessments that we do. They generally run from end of July or beginning of August to the end of October. And we are doing different apple cultivars. It's mainly focused for apples. So now we can go into describe a little bit each one of these maturity indices and how do we measure them, okay? So you see that it's pretty simple. So first talking about color. One of the indices is this change in background color that happens in apples and in many other fruits, from a more greenish to a more yellowish or even more a creamy color, okay? Which is an indicator of that the fruit is ripening. So this is, for example, very important in cultivars such as Gala or Fuji. It's more difficult to implement, of course, in cultivars that are totally red in color. And what we do is really just use these color chips and you just compare the color of your apple versus these chips and you try to match which is the color that is representing your sample. Okay? Each one of these colors is going to have a name. So you have whatever, green yellowish or creamy yellowish, etc., etc. And then you can give names to each one of your samples in the different weeks of evaluation. So when you have fruit that is going to be targeting a long-term storage, that you want to keep it for more than 3 months in storage, you really try to harvest the fruit when there is a change in background color from a greenish to a yellowish color. But when you have fruit that is going to just store it for a short period of time, less than a month, you can harvest the fruit when there is a change of background color from yellow to a more creamy. Okay, so we are talking about a color like this versus when you are talking about longer storage that you can go maybe in these categories here. Okay? So that's really simple for how can we assess changes in background color. Now, we do have a way to also assess this in a more objective way, giving it a number. Okay, and I just want to introduce so that you are aware that there is this instrument that we call the DA meter, or difference of absorbance meter. And what this does is really quantify the amount of chlorophyll that is present in the skin of the fruit. As we know, as the fruit ripens, the chlorophyll is going to decrease, so we are expecting a decrease in the numbers that we get from this instrument as the fruit is ripening. It is a handheld device, as you can see here. It is used for fruits that are attached or detached from the tree. What it does, it really shines a LED light into the apple, and there's a sensor that measures how much light is reflecting back out. It is measuring what we call the index of absorbance difference, which really relates to the actual content of chlorophyll A that is present in the fruit skin. As I said, these values are expected to decrease as the fruit is ripening, and the values can be as high as almost 1.5 or 2 when the fruit is really, really green. And then when we are thinking of fruits that we want to store for a long term, we are trying to target values of 0.6, 0.7, depending on the cultivar, but this is just very general. And when we are talking about fruit that is going for short-term storage, we are looking for values that are a little bit lower, in the 0.3, 0.4 range. Okay? So these are the ways to assess color, more from a subjective, using these cards, and also from an objective perspective if we want to really get a value for it. Any questions so far? You're good? Okay. Then let's move to the fruit size. This is also an important index that we are all very aware of. So here I'm just showing you two different ways in which you can measure this. One of them is what we call the Cranston fruit gauge. It's very simple. It fits in the pocket. It requires one hand to operate. There's no electronics, just tough plastic parts and a steel spring band. And all you do is, it's how it looks here in the picture. You just slide your thumb to tighten the band around the apple, and then you read the value that you are getting. Okay? And the measurement range that this instrument has is from 0.8 to 4. So very straightforward and simple. Or the other option is to use a fruit caliper, which also fits in the pocket, and you can have more like a dial caliper, or you can also have a digital one that is also going to give you a specific value as you just measure the diameter of that fruit. And you can follow the size throughout the different weeks of evaluation. Now, moving into what happens with the firmness and the loss of firmness that is going to happen throughout ripening. What we really do here is use an instrument that is going to help us determine the amount of pressure that is required to puncture the flesh of the fruit without skin. And for that, we use an instrument that is called the Ph.D. penetrometer. So how this works is also very simple, believe me. We have a peeler that comes with the instrument, or you can even use a knife. And all that you do is just remove a skin disc in the size of a quarter coin in both sides of the apples, midway between the stem end and the calyx. So you first just peel your apple in those sizes. Then you are going to choose the 7 and 16-inch tip here for assessing apples, because the instrument comes with two different types of probes or tips. The 5 and 16-inch is for stone fruits, but the 7 and 16-inch is for apples. You can do exactly the same for stone fruits too. What we do next is we are going to place our fruit against a fixed and strong surface, as you can see in the picture, and we are going to penetrate it with the tip into the flesh of the fruit until the marked line. There is a line in the probe, and you just go until there. What is key about this is to apply a penetration force that is soft and that is uniform, and you generally try to pay attention to the speed of the penetration. Around 2 seconds should be necessary to push this tip under a constant speed. So this is a very fast measurement. And you generally can read with a 0.5 pound precision. And what you try to do is to measure both sides of the fruit in order to obtain an average. You should get very similar measurements in both sides. Okay? So here is where you read your result, and then you just average. You can read it in pounds or in kilograms too. Now, when we have fruit, and this is an example specifically for Honeycrisp, when we have Honeycrisp fruit that is targeted to be stored for a long term, for more than 3 months, we are trying to harvest fruits when they are in their firmness range of 15 to 16 pounds. But when we have Honeycrisp fruits that are going to be sold very fast, we can harvest these fruits with a firmness lower than 15 pounds, even getting to 13. Okay? That's with respect to firmness. Now, another very important index, and very easy to implement too, is to be able to monitor what's happening with the starch content in the fruits. Again, as the fruit is going to be ripening, the starch in the fruit flesh is going to be decreasing because it's going to be converted into sugars. So our starch will go down and our sugars will start going up. So the stage of maturity of apples can be determined performing this simple starch iodine test. What the principle of this test is that the iodine is capable to bind to the starch molecules that are present in the apple flesh. And when that happens, it turns the flesh into this blue-black coloration, while the cells that only contain sugars or do not contain starch will have no color change. And what this test records is the degree of starch disappearance in the flesh as the starch concentration is going to decrease as the fruit matures. So here I'm showing you a picture of Gala fruit, and we assess them for 3 consecutive weeks. And you can see how at week 1, there's a lot of this blue-black coloration in the flesh because the fruit is full of starch. But as the fruit continues ripening, you can see by week 3, it's almost all gone. There's still starch present, but in a lower percentage. Now, this is just a little bit of safety when performing this test. The starch solution is poisonous, so it will permanently stain anything. You always have to use gloves when performing this test. Keep out of children. It's very important to store the solution in an opaque or foil-covered bottle, because if not, it's going to fade and it's not going to be doing what we need it to do. The lid of the bottle should not be metallic because it can disintegrate metals. It has to be clearly marked with a skull and the crow's bones to make sure that people know that that is poisonous. The evaluated apples should not be used as a compost or for animal feed, never. And here I just talk a little bit of how to prepare this, but there's also ways to purchase this directly, okay? So if we go a little bit more in detail on how we proceed with these measurements, the very first thing you're going to do is just cut an apple in half horizontally around its equator, as you can see here in the picture. And then you will apply this starch iodine solution to the cut surface of one of the halves. Generally, it's the half that has the stem, okay? You can do this by spraying onto the flesh, or you can put it in a container that already has a little bit of the solution, and you just place your apples there. You leave it for 1 minute, then you drain the excess solution, and you turn the apple on the other side, looking upwards, and then you wait 2 minutes for the solution to react with the flesh. And you are going to start seeing these different patterns of coloration that appear in the different apples. The objective of this test is to be able to compare the pattern of each one of these stained apple halves with the pictures on a specific chart and choose the picture that most closely represents what you are observing. And this is the type of charts that we use. This is a very standard starch chart that is used to evaluate the starch index. It was developed in Cornell for Macintosh apples a long time ago, but it has been kind of the big standard used until nowadays. So it goes from a scale of 1, where the fruit, as you can see, is 100% full of starch, to 8, where there is no starch in the fruit at all. So what you do really is just compare the pattern that you obtain from your apples to which one of these numbers does it resemble the most. And then you have your starch index. When we are thinking about long-term storage of apples, we are looking for values that are between the 3 and the 5 index. But when we are talking about fruits that are going to be stored for a very short time, we can go further up into 6 or 7, okay? When most of the starch already has disappeared. I just wanted to bring to your attention that there's also starch index charts that have been developed for specific cultivars. So this is one, for example, coming from Washington, which was developed specifically for Honeycrisp. It's exactly the same way it works. It's just, in this case, it goes from 1 to 6. Okay? And the patterns that you are going to see are more specifically related for what you would see in Honeycrisp fruit. Then, as we said, starch is going to decrease. And what is going to happen? The sugar contents are going to be increasing as the fruit ripens. So how can we monitor those changes in sugars? And for that, we use what we call the refractometer. You have a manual one, as you can see in the picture, or a digital one, okay? So generally, to do this, we use this instrument to measure the percentage of sugars or the percentage of soluble solids. It's exactly the same. And we use an extracted amount of juice from our samples. The SSC, or this sugar content, has been shown to work as an effective approximation to the percentage of sugar content that is present on the fruit. And the principle of work of this instrument is just that it measures the deflection of the light as it passes through the fruit juice, and it's going to scale the refractive index in what we call the percentage of soluble solids, or you can also hear about the degree Brix. It's all the same, talking about the content of sugars in the fruits. Generally, we recommend to harvest apples with readings that are between 12 and 14% of soluble solid contents, but this can really vary according to the cultivar or the strain or the target markets of the fruits. How do we measure this? Again, it's very simple. You generally are going to just cut 2 slices of apples from both sides of the fruit. Each slice needs to be cut longitudinally from the stem to the calyx end, as you can see here in the picture. Then you can use a garlic press to obtain some drops of juice. You are going to place 2 or 3 drops of this juice on this prism of the instrument, and you can press start if you are talking about a digital one, or you will just close the lid if you are talking about a manual one. And then you are going to be able to get your measurement. You have to clear the prism between each measurement with distilled water and a Kim wipe, and we remember to calibrate the instrument until you really get a 0 value before proceeding into the next sample. And as I said, we are generally targeting a value that is not lower than 12% of soluble solid contents when harvesting apples. And then there's other maturity indices that I am not going to go into, but that I mentioned already, but just to give a little bit more reinforcement. We also have the changes in seed color from a whiter to a more darker color is also an important index in apples. The changes in fruit flavor, you can do this subjectively or also objectively in the lab, but it's always an important practice to just try out your fruit and see how it is tasting. There's also an index related with the increase in ethylene production. We can measure this in the lab exactly. We have an instrument called gas chromatograph, which is going to allow us to know exactly the production of ethylene of each fruit, and we can monitor this throughout time. The same with the increase in respiration rate, changes in production of aroma volatiles, and also the loss of acidity. We also have an instrument in the lab where we can monitor how is the acidity evolving throughout ripening. And here I just put an example of the type of sheets that we used when we do this in the lab. You just have your fruit samples, and then you have different columns where you have your different indices that you are measuring, and you can record your values, and you do this per week, so then you can always be comparing your values and be using this as a tool to help you make decisions, because that's the objective. And then just to wrap up, important considerations. Determination of apple fruit maturity and optimal harvest date can be achieved by using different maturity indices, as we saw. It is very important to take into account several indices when making any decision. None of the individual indices alone will explain the true maturity stage of an apple. So not only measuring size is going to tell you, okay, this apple is ready for harvest. At least you have to combine 2 or 3 of these indices in order to be able to make an informed decision. The relative importance of the maturity indices and their ranges will be defined by the cultivar or the strain, and always by the fruit target market. As I tried to show you, if you are targeting a long-term versus a short-term storage, the indices are going to vary what we are looking for. It is of crucial importance to collect a representative sample of apple fruits, to conduct maturity tests, and start monitoring fruit weekly around 4 weeks before the anticipated harvest dates. The consistency is really just the crucial. And don't forget to try the fruit. So with that, I just wanted to share with you so that you can see that how this is done. We did a video in the lab. My students did it really. And they are proceeding to measure many of these indices in the lab. So I wanted to share it with you.
In the Farcuh lab, we investigate how to develop novel strategies for improving fruit quality, nutritional value, shelf life capacity, safety, and marketability.
In this video, we will demonstrate how to assess fruit maturity using different maturity indices that are useful to determine optimal harvest time.
We'll start with color changes. Changes in the surface color, or the part of the skin colored red, and the background color, the part of the skin colored yellow or green, are important maturity indices. Generally, for the surface color of red-colored cultivars, the indicated for its commercial grade will be based on the percentage of the surface of the fruit that has a good shade of red color. The more color, the better the grade. For example, in the case of Honeycrisp, the acceptable minimum color for the retail sector is 50 to 60% red coloration with no hard green. For measuring changes in background color, we use a difference of absorbance meter or DA meter. Here, Sheepon is performing the calibration. The DA meter is a device that measures the index of absorbance difference, or IAD, which relates to the actual content of chlorophyll A in the skin during fruit ripening. The DA meter is a handheld device that shines LED light into the apple, and the sensor measures how much light reflects back. Values of IAD will decrease as the fruit ripens and chlorophyll degrades. For each apple cultivar, a characteristic DA index can be developed. DA index readings of 0.6 to 0.7 are recommended for long-term storage, while 0.35 index values are recommended for short-term storage. Another important index corresponds to fruit firmness changes. As fruit matures and ripens, the flesh becomes softer. As flesh firmness highly correlates with post-harvest storage quality, firmness is a key aspect to measure for long-term storage. Fruit firmness, or pressure testers such as penetrometers, have been developed to measure these changes. These instruments determine the amount of pressure required to puncture the flesh of the fruit without the skin. For testing, remove a disc of skin between the size of a nickel and a quarter on both the blush and the non-blush side of the apple. Against a hard surface, force the tip of the plunger into the fruit of the exposed flesh. It should take 2 seconds to push the plunger in at a consistent speed. Applying pressure too fast can result in an inaccurate reading. Measure both sides and average the readings to determine the value. In general, apples that are destined for long-term storage should be harvested with a firmness of at least 15 pounds, while fruit for shorter-term storage should be harvested with 13 to 15 pounds. Starch content changes are another important maturity index in apples. Starch in the fruit flesh is converted to sugars as apples mature and ripen. The maturity stage of apples can be determined by performing a simple starch iodine test, which records the degree of starch disappearance in the flesh. As iodine binds to the starch molecules in the apple flesh, a blue-black coloration develops. Cells that contain sugars will have no color change. Iodine solution can be purchased ready to use and is kept in a well-labeled opaque container or wrapped with aluminum foil, as it will fade if exposed to light. Gloves should always be worn to avoid skin contact, and tested apples should not be used as compost or for animal feed, as it is highly poisonous. To perform the starch iodine test, cut an apple in half horizontally soluble solids of an extracted fruit juice sample. Fruit juice as a byproduct of the firmness testing or fresh pressed juice can be used. Measurements are performed by squeezing a small amount of juice into the device's prism. After each juice sample, the prism surface should be rinsed with distilled water and carefully wiped with a soft tissue to prevent contamination between samples. It is recommended to harvest apples with readings of around 12 to 14% SSC, but the ideal reading will vary by cultivar and selected market for the fruits. Determination of apple harvest maturity and optimal harvest dates can be achieved using different maturity indices. A good strategy is to take into account several indices when making harvest and storage decisions, especially as weather conditions become increasingly unpredictable with climate change. This is important as an individual maturity index cannot explain the true maturity status of an apple. As each cultivar and even orchard block will vary on the maturity indices, it's important to collect a fully representative sample of apples to conduct these maturity tests. Fruits should be monitored weekly starting around 4 to 5 weeks before the anticipated harvest date. Thank you for watching and happy harvesting.
Have you ever wondered why bread rises, why an apple turns?
Sorry, that was not part of it. Okay, and that's what I had to share. I want to thank you for the attention. I'm happy to take questions. And before the questions, I want to say that inside your folder, if you could help me with this, there is a survey directly, specifically about this talk. If you could fill it out, that would help me a lot. So thanks for that. Yes?
Which of the indices do you put the highest priority or highest weight on in that situation? Whereas if you have conflicting results, which ones would you listen to more?
Yeah, that's a very good question. Generally, that's why we kind of try to look at all of them together, because that might happen. So I would say the change in background color is an important one, the firmness is an important one, the starch content is an important one. Sugars, generally you will get it if you are in the correct starch level, but generally if you are lower than 12 and you are also going to try your fruit, I think you are going to notice it. So I would say those three are really, really important.
So I don't need to run out and buy a $5,000 DA meter?
The DA meter, it's useful, and it has become more and more, because more and more research groups are trying to establish these ranges, and now even for different cultivars. At the beginning it was mainly used and targeted for peaches. It was developed by Italians for peaches, but it has more and more being incorporated into apples, and it's really working nicely for us too. But there's also the option of the chips, and as you get more and more familiar with those, it also can be a very viable option, I think, more than just having to buy the DA meter. Any other questions?
So those gadgets are commonly used? They don't just cut it open and look at the seed? I'm just trying to think, my family raises apples at home and they do cold storage, and I didn't think, I'm curious, and I'm going to ask my brother. So they use these techniques mostly now in farming too.
Yeah. Yeah, the truth is, well, since I am here in Maryland, I am trying to kind of make people aware of this, because it's a tool to just make a better decision. Many times what I've seen is growers just try to go for the color, and I'm talking more about the red color development in apples, because better red color would be a better market, a better price. But what happens with the real quality of that fruit? It's kind of, sometimes it's overripe, sometimes it's left in the tree too long. So especially if you are storing it, it's like if you are just selling immediately, maybe this does not have so much relevance, or you can just target specific indices. But especially when you are trying to keep your fruit for a little longer time, it's important to harvest in the correct time. And it's not going to be the same every year. It can totally vary. So it is an important practice, and it's really not so difficult to implement. It's you don't need to purchase the 5,000 DA meter, but the penetrometer is like $200. These things are not, the starch test is just a solution. It's not something, and it doesn't take a lot of time to do this also. You are just doing a couple of apples. So I think it's an important practice to consider, and what can help to just really increase your profits at the end, because you are going to have fruit with a higher quality. That's the message, really. Any of you are using any of these or had heard about them before? No?
What?
About the maturity indices?
Refractometer? The refractometer?
Yeah, any of these.
Yeah,
Yes.
they're well worth the cost if you do fruit farming, especially for apples and peaches.
Yeah. Well, that's it. And please help me with the survey. I would appreciate it. Thank you so much.